All right, good morning, everybody. Welcome to a special Saturday edition of the stream. Special because yesterday's stream obviously did not work, and so we are making it up today. So apologies again about that. I don't know what was going on with the internet. I don't know if it was the internet or just the server that I use for streaming that just was not working yesterday. But unfortunately, our stream did, crapped out about around the 10-minute mark. So because it was so soon in the stream, and I honestly can't remember where we left off, we're going to pretend like yesterday didn't happen and basically start from scratch. So if you did tune in yesterday, I apologize that the first 10 minutes here are probably going to be will be pretty much the exact same. So hopefully we have better luck today with our connectivity issues. So today, what we are going to cover, one quick item of business before getting into it. There will not be a live stream next week. I mentioned yesterday that my wife is going to visit our new niece in Colorado. She's leaving next Thursday and then is going to be gone the whole weekend. So it's just me and my girls here at the house. So I got to watch them, and unfortunately we won't have the time to do the stream. So so anyway, today's stream, what we're going to cover is an introduction to LaTeX. So if you are not familiar with what LaTeX is, if you think about mathematical equations and how, people write them on chalkboards or whiteboards or anything, they have these special characters and stuff, and they look very specific. And so LaTeX is basically a way to write what looks like code to actually produce a visualization of the mathematical equations appropriately. I'm couching it in this way because, I like to do these streams as like a live coding stream. And so in a sense, this is going to look very much like code, but it is not true code per se. And let's go ahead and jump into a very quick example of what I'm going to show, but not necessarily cover quite I'm just going to show really quick what it is, and then we're going to work backwards from an intuition of why we want to do this. And then this is going to be a kind of a two-in-one kind of stream. So this is going to be a stream where we're actually going to work through an example with a very basic Algebra 1 exponents lesson. So, if you are not strong, if you are somebody who considers themselves not strong in math, don't worry. I'm going to try to make this as intuitive as possible. And I think I even put in there, like, as long as you've passed through 3rd or 4th grade math, then you'll be fine. Very basic algebra. And so if you actually recall, and I didn't pull this up. I should have pulled this up. What did I do with that? Sorry, folks. I'm missing something here. I don't know what I did with that screenshot. But anyway, there is a specific math problem that we're going to work through. Oh, that's what I wanted to pull up. It was on Twitter. Okay, so it was actually in the title card of the stream. Where's my tweet? Because I retweeted it. So if you follow me on Twitter, I actually retweeted this particular account here. And this particular account's a pretty cool follow because this person posts like math problems like this all the time. And so at the end of this stream, we're going to be able to solve this problem here. And I'll represent it appropriately in LaTeX. And you'll actually see that you can, once we actually start to understand some of the mathematical principles, there's actually a very simple solution to this. There's no calculator required. I know we see some big numbers here, 2 to the 17th power. I have no idea what that is off the top of my head. I would definitely need a calculator for that. I can tell you that, you might need a pen and paper to work this part out, but there is no need to solve this problem with a calculator. So we will revisit this problem at the end. But anyway, so let's give a very brief introduction of what LaTeX kind of is. So this is, for those of you who are not aware, this is a Jupyter notebook. Oh, by the way, one other quick comment. I am monitoring for questions on LinkedIn and YouTube. So if you have any questions, feel free to ask along the way, and I'll see about answering if I can. Okay, so this is a Jupyter notebook. If you're not familiar with what a Jupyter notebook is, this is an environment that a lot of data scientists use because it's a great way to do a combination of both of both writing code, and usually in the form of Python, sometimes in the form of R, and then also like describing it in the midst, like with plain text language with what is known as markdown cell. So I already have one markdown cell here. It's kind of hard to tell because I've already run it. Ignore this because that was just a personal note for me. But basically, so let me give a very quick demonstration here. So for those of you who are not familiar with Jupyter Notebooks, so the nice thing about these is I can run my Python code here. So let's say I wanted to import some Python libraries. So we're not going to use these Python libraries in today's stream, but I'm just using this as an example. So I'm going to import these Python libraries as PD. So this is actual Python code that is running. And then I could, actually continue to write additional Python code. So, if I wanted to write print hello world and run that, it's going to print hello world. Now, if I wanted to describe what I did above, I can turn these cells into what is known as a markdown cell. And this is going to allow us to basically write plain text language for what we just did above. So I'm going to write here in the cells above, I wrote some basic code. This cell is that I am typing in right now is known as a markdown cell. Okay, and then when I run this cell, if you will, then it turns it into plain text language. Now, this is I did not do anything like fancy at all, but Markdown does have some special stuff to it. So if I add the double asterisk before and after the word markdown here and I run, now you can see that this markdown word has been bolded. And there's a lot of different things that you can do with markdown in this context. So you'll see here that if you put like a pound sign or a hashtag sign in front of here, that actually creates like a header, or if you do like two hashtags. So if I do, so this is header level 2 or 3, I think it goes up to 5, header level 3, then you can see that we start to get smaller and smaller header levels. So the cool thing about this markdown is, by natively speaking, it doesn't necessarily have the ability to write these mathematical equations, but what it does instead is it incorporates what is known as LaTeX, and LaTeX allows us to write mathematical equations in something that looks really nice. So let me just show this really quick, but we're going to come back to discussing the syntax later on as we continue this presentation. So let's say if I wanted to do 2 to the 4th power, or 2 to the third power, because that, I don't want to go or type too much right now. So 2 to the 3rd power equals 2 times 2 times 2 times 2, and then I dollar sign it, close it with the dollar signs. So now you can see that what it did was it made it look like you just would write it as if I were to write it on a chalkboard here. And so that is also why so this screen here, I actually have my Microsoft Surface down here, and that's why I've got my pen here, so we're actually going to handwrite some stuff. So hello everybody. My handwriting is terrible, but I'll be a little bit better with the numbers. So we are actually going to show how we might handwrite some things first, and then see how we can actually translate it into LaTeX later. So I hope you can start to see the intuition of why this is really powerful for data science work, because we can do a whole lot here. We can talk about what we did. We can appropriately show it with LaTeX in mathematical form, and then we can actually even run things with Python. So let's say, well, I'm jumping ahead of myself. So the one thing I do want to note before we jump into this is, trying to understand what is this whole, like, why is math so funky looking? And so the one thing, let's do an example here. So, because a lot of people, I think math is really daunting because math has all these funky symbols going on and stuff, and it doesn't really make a whole lot of intuitive sense of what's going on necessarily sometimes. And so really what math is a shorthand way of representing ideas that are too long to write out by plain text. So actually, if we were to try to take this and then write this out as plain text, it would just be what? 2 to the 3rd power equals 2 times 2 multiplied by 2 and multiplied by 2 again. Okay. So if you read this out, like by like a general understanding, like this is kind of a difficult to understand what this is saying, like, and that we can't really do some algebraic manipulation with this thing, and we're not going to necessarily touch on that too terribly much at the moment, but basically what I'm trying to say is like this is too long. Like if we were mathematicians and we were to write out all of our math equations by like plain language English like this, it would be crazy. Like this would, because this is actually not too bad. Like we were able to accomplish pretty simply. But let's say I wanted to do something else. So I'm going to show, this is probably going to be actually easier to write or handwrite than it is to actually type down by hand. So let's say I have this here. So, and I'll explain what this here is in a second. And this is, we're not going to get too overly complex here today with this, but I'm going to talk about what this means here. Okay. Well, I guess that's not supposed to be an X. That's supposed to be an N. So 2N. Okay, so that is terrible handwriting. So again, forgive me for my handwriting here. So what this is basically saying, so what this big E-like shape right here is, and I'll change the color. So this E-right shape here is known as a sigma, and so this is an alpha, a Greek letter, if you will. Not if you will, it is a Greek letter. And what this represents is a summation or an addition of all numbers. So what this is basically saying is, for every number starting from number 1, so from number 1 all the way going up to number 10, I want to know what is that number times 2 plus 3. So let's just do like the first one. So the first one is going to be n equals 1. So if n equals 1, so that would be, so basically we're going to substitute the n here. So 2, or I'm sorry, trying to talk and write at the same time is apparently not a skill of mine. 2n plus 3. So what we are going to do is we're going to pop in this 1 here in place of this, where this n represents here. So 2 times 2 is, or 2 times 1 is 2, plus 3. Oh my gosh, can't write right now. 2 plus 3 equals 5. So that is 5. So for when n equals 1, this value is 5. So we got 5. Now if we were to do this for 2, now let's say n equals 2. N equals 2. I'm going to erase some of the stuff here. N equals 2. Then we have 2. Let me change colors again. All right, so we have 2. And then we're going to pop in a 2 here. Why do I keep doing that? Oh my gosh, I keep wanting to skip ahead. All right, so what this is end up going to be, so, oops, sorry about that. So 2 times 2 is 4, plus 3 is 7. Now try to imagine representing this by plain language English. It's basically impossible. Like it's not impossible, but like you would have like a full like 10-page paper basically to represent what I just represented here in English language. And so that's why we, mathematicians use this shorthand, and it can be confusing at first, but when you start to understand that these things really have a correlative representation of something that's not necessarily, it actually does like correlate to like something that's plain English, and it's actually easier to understand this in the form of code. So this is actually something that we can kind of do cool with Python here as well. So like, let's go back to my Jupyter notebook, and I actually didn't want to represent this, well, I don't want to represent that quite yet. So, but basically, so we can do the same thing. Or actually, let me go ahead and show the syntax here. So let's say I wanted to write this in LaTeX. I'm a little bit out of order because I'm scatterbrained from yesterday. So I feel like I'm not going in the order that I wanted to necessarily. But anyway, so let's go ahead and I guess jump into the syntax of what LaTeX is. So we already showed a very basic example up here. So you'll notice that, we are wrapping this with the dollar signs here. So there's actually 2 different forms of LaTeX, at least in the form of Markdown. You can use $1 sign or $2 signs. $2 signs is going to put it in what is called presentation mode. And presentation mode just basically, as you can kind of see here, centers it on the screen. And if you were to use just $1 sign, and then the $1 sign does it like justified to whatever the sentence already is. So let's say, let me do a very basic one. 2 plus 2 in LaTeX is 2 plus 2 $sign. I guess that's kind of hard to tell. I mean, that is true. Well, I guess let's do 2 to the power of 2. That way, because that 2 to the power of 2, because that one you can actually will be able to see a little bit better. So that is 2 caret sign 2, and now you can see it. So 2 to the power of 2, that's 2 squared. So that's, you could see that it's putting it in line and not centering that. So that is if you do $1 sign. Now, if I were to do $2 signs, so that's $2 signs, and then you can actually do a multi-line kind of thing here. So 2 to the power of 2 is that, and then I do close it off with the dollar signs. And now we have what is known as the presentation mode version of LaTeX, which is centering it and making it nice and pretty right smack dab in the center there of that cell. Okay, so that is that's the basic introduction to LaTeX. So actually, there's more than just the dollar signs. Like I've seen like how you can do some other ways of initiating LaTeX, but basically the simplest way to initiate the LaTeX syntax is by wrapping in these dollar signs. I actually prefer the display mode version, which is the $2 signs, and then writing out whatever you want to write out, and then closing it out with the $2 signs. So if you want to do what I wrote here in my other, in this here, where I did this very poorly written thing. So let me go ahead and write that down. So what that would be is in Markdown, I'm going to do the $2 signs, and I'm going to go ahead and close it off with the $2 sign. So that is going to be, so it's going to be the \sum underscore n equals 1, curly braces, to the, or I'm sorry, not to the, caret, curly brace, 10, and then 2n plus 3. Okay, so I think that I did that right. Yeah, I did that right. Okay, so what that is, again, in presentation mode here, so this is saying for every number from 1 to 10, I want to add all those together when n is 2n plus 3. So now if I wanted to execute this in Python, so this is the really cool thing about Python, and this is why the Jupyter notebooks are so beloved by the data science community, is so I just represented this in the form of LaTeX in something that any mathematician can understand, and now I can go and run this in a Python variant. So I got to remember the syntax here. So final sum, I'm going to create a variable that says final sum equals 0, because we're going to end up like setting this final sum to equal something here in the end. So for n in range, I'm going to do 1 to 10. I think this is right. Hold on, let me print this out. So print n, I guess it's 1 to 11. So basically this is saying, so for n in range 1 to 11, and remember, because of how Python Python indexing works, I'm gonna need to blow my nose here in a second. How Python indexing works, the reason we have to go to 11 is because it starts at index value 0. So if we want to get 1 to 10, we have to stop at 11. So this is basically saying we want everything from 1 to right before 11 hits. So that probably doesn't make much sense. I'm probably explaining it really poorly right now, but as we just printed out, so we are getting the 1 through 10 here. So what we want to do is what is our problem? So we want to do 2n plus 3. So final. So we're going to increment our sum. Final sum equals 2 times, or I'm going to put this in print, 2 times n plus 3. Okay, so that is so that's what this whole thing is going to do. And then after we finish this whole thing, then we can print it out. So print final sum, and then, so that, is that correct? I don't know if that's correct. That doesn't seem right. Or I probably did something wrong. Oh, okay. I know what I did wrong. All right. So it's actually plus equals. I'm sorry. Plus equals. There we go. So what this is basically doing is that every time we go through one of these iterations of the loop, is we will add the sum to the full thing, and then have this cumulative sum here at the end. And so again, this is, don't worry too much if we're getting a little bit lost in the code here. What I'm trying to do is build this intuition of the reason that Jupyter notebooks are so cool and LaTeX is really cool and this whole combination is really cool is I can represent this in plain mathematical language. I can share this with my peers, and then I can execute it in the form of code in Python. So that is the holistic intuition of why this whole thing is cool. Now, I hope this makes sense. Now that we went through a lot of concepts really fast, so we're going to take a step back now, and we're going to go a little bit slower with something that's a little bit simpler, and that is an understanding of how to work with exponents. All right, so again, like I said, if you if you would consider yourself not great on math, no worries, because the only thing that you need to know going forward is basic arithmetic. I tried to combine the words together, and it came out as basic. So, all right. So what is again? So back to this whole idea of mathematics. The symbols and everything are a shorthand for condensing larger ideas. So let's come back to my like physical, or like my writing board, if you will. So like let's say like I have, I want to take 2 times 2 times 2 times 2. All right, so that is basically saying, I want to take 2 multiplied by 2 multiplied by 2 multiplied by 2. So we know that 2 times 2 is 4 times 2, and then so 2 times 2 is 4, and then 2 times 2 is 4, so that's 4 times 4. So this whole thing is going to end up being 16. So this is pretty simple to represent. Now, the mathematical shorthand for doing 2 times 2 times 2 times 2 is what we call the exponents, and so what we do is represent this right here. Here, let me change colors so we're being clear. So we're going to take this right here, and this equals 2 to the 4th power. And I'm making it big just so it makes sense what I'm trying to do here. So I hope that makes sense. So this is the same thing as what we represented here by our longhand form. So if we had, I don't know, 2 times 2 times 2 times 2 times 2 times 2. How many 2s is that? 1, 2, 3, 4, 5, 6. So that would be, so this right here is the same as 2 to the 6th power. So I hope that makes sense. Now, so now we have 2 to the 4th power and 2 to the 6th power. So let's say we are given a problem where we are saying, asked, what is 2 to the 4th power? 2 to the 4th power. Here, let me scroll down. Let's say we are asked, what is 2 to the 4th power times 2 to the 6th power? Well, now let's go ahead and expand this thing out, because this is where, things can, because, one of the things that I was taught is how to actually do things in the end, like what is the shortcut way to get to the end. But I actually think it's better to build the intuition of understanding how we're getting there. So this is basically saying, so this is remember, coming back up here, so 2 to the 4th is the same as 2 times 2 times 2 times 2, and then we have 2 to the 6th, that's the same as thing as 2 times 2 times 2 times 2 times 2 times 2. So if we were to expand this out, so this would be let me change the colors here. So 2 to the 4th is going to be represented by blue, times 2 to the 6th. I'm using too big of numbers here. So 2 to the 6th is going to be represented by green here. So if we were to expand this out, so that would be 2 times 2 times 2 times 2 times, and then we got the 6 2s over here. So 2, 2, oh my gosh, 2, 2, 2. All right, I used too big of exponents there. But now you can kind of get a better understanding here of, so if we had 4 2s before that represented 2 to the 4th, and then we have 6 2s here that are 2 to the 6th. Now what is this whole thing together? And we're going to change to purple. So this whole thing together, so we have 1 2 3 4 5 6 7 8 9 10 10 2s. So 2 to the 10th. Now, if we were to go back and look at this here, so this, remember, this expression here in purple, this expression here in purple is the same thing as the expression up here, 2 to the 4th, 2 to the 6th. So that is, so what we could say here is 2 to the 4th times 2 to the 6th. I'm going to put them in parentheses, 2 to the 6th. Oh my gosh, I'm really bad about changing colors. I don't know if y'all can tell, I've never taught a math class like this before. So 2 to the 4th times 2 to the 6th. Now you can see the 4 and the 6 are basically, if basically 2 to the 4th plus 6 equals 2 to the 10th. So what we basically did here at the end of this whole thing is when we did the 2 to the 4th times 2 to the 6th, we basically just added the exponents together. And I hope you can see where we kind of derived that from. Again, so we got the 2 to the 4th, so we got our 4 2's here, and we got our 6 2's here. So when we count them all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we get this value right here. Now, let's go ahead and represent this in LaTeX, what I'm trying to note here. So, if I have, and I'm actually going to maybe make the numbers a little bit simpler because I don't want to have to type out this whole thing. So if I wanted to represent this as LaTeX, we would say, we would change this to a markdown cell first. So this needs to be a markdown cell. Here, let me make a new, like a header here. So exponents, we'll just call exponents. All right, so exponents. All right, I'm going to zoom in here a little bit. Oh, wait, I got to change the markdown first. All right, now let's zoom in a little bit. All right, so remember, I like to use the syntax where we're using the dollar signs. So we're basically saying we want to do 2 to the 4th, 2 to the 4th times 2 to the 6th. And remember, we basically said this is the same thing as 2 times 2 times 2 times, oh my gosh, 2 times 2. All right. Is that right? Here, hold on. I want to just check really quick. Okay, so that is correct. And then that is the same thing as here. 2 times 2 times 2. And we got to add 2 more times 2's times 2 times 2. All right, just making sure that my connection is still working. All right. Okay, so now you can see we represented basically the same thing that we did here in LaTeX. So if 2 to the 4th times 2 to the 6th equals 2 times 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 2, that is all basically at the end of the day going to be 2. So 2. Well, I guess we could just represent it on the same line here. So that's going to be the same thing as 2 to the 10th. Okay, so that is the, oops. Oh, that is, okay, so this is one little gotcha with LaTeX that I found, is if you try to do like what is known as a superscript, because it's known as a superscript because as you can see, like the 4 is up a little bit higher, or the 6 is a little bit up higher here. So if you try to do a superscript here, like with multiple digits, like it does that weird business that you just saw where it's like 2 to the 1 and then like the 0 is just kind of hanging out. In order to fix that, in traditional programming, you just wrap that in like parentheses. In LaTeX, you have to wrap it with what are known as these curly braces, the left and right curly brace here, and that'll fix the problem there. Okay, so that is very basic understanding of how to multiply exponents together. So that is hopefully a more intuitive way of understanding how to do the exponents like that. Now, let's say you wanted to do the opposite, or not the opposite, but you wanted to take 2 to the 4th divided by 2 to the 6th. All right, so let's go back to our thing here, my surface, and I'm going to go ahead and erase all this. By the way, I freaking love the Surface for doing mathematical equations, particularly because, so this is the Surface Pen. I did use an iPad for the longest time, and I like the iPad or the Apple Pencil. The only thing with the Apple Pencil is it does not have the eraser functionality that the Surface Pen does. So I don't know if you could see this, and I'm not going to show too much because my camera gets all weird with the focus. But basically, like the blunt end of the stylus serves as an eraser on the surface. So I can actually just go through and erase this whole thing like you are seeing right now. So I really love this thing. And so, by the way, this is the program that I'm using on my Surface here for writing is known as Nebo. I can't remember if that was free or if I had to pay. If I had to pay, it was pretty cheap. Definitely worth it though. Highly recommend Nebo. It's not a mathematical. It's a general like notebook kind of thing. But I'm using it for math, and I really like to use it in this context. So anyway, so we had 2 to the 6th over. So like let's say we have 2 to the 6th, and we want to go to 2 to the 4th. All right, so now recall. How do we handle this? So some of you might be seeing this right away, but let's just back out for a second to do a bit of a more intuitive understanding here. So remember, 2 to the 6th, and I guess I should have done this in different colors. So 2 to the 6th over 2 to the 4th. Okay. All right, now remember, so this is the same as 2 times 2 times 2 times 2 times 2 times 2. Okay, so we got all that, and that's going to be all over. So this guy, so 2 to the 4th is 2 times 2 times 2 times 2. All right, that does not look like a times. That's the one problem with using the X when I write them out. They sometimes look like plus signs. Okay, so now this may start to make more of an intuitive sense now, because basically what this is represented as here is you can re-represent these as like individualized fractions. So like let me regroup these. So down here, so I'm gonna do 2, 2, 2, 2, 2, 2. All right, so this is basically going to be all right, this is not gonna make much sense to some people here, but some people know what I'm doing here, but it'll make sense here in a second. So we have our 2's on the top. So that's basically because what we're doing is parsing these out as individualized fractions now. And so if I were to take the green now, so if I were to do 1, 2, 3, 4, and then we have our 2 2's left over, so that's gonna be 2 to 1. Or 1. So what these are all basically doing, and I'm trying to represent here very simply, is these are all basically canceling each other out. So because 2 over 2 equals 1. So this is going to equal 1, this is going to equal 1, this is going to equal 1, and this is going to equal 1. And the reason we can cancel those out is because anything times 1 is going to be by itself. So all we have left over here is 2 over 1 times 2 over 1. So 2 over 1 times 2 over 1, that's the same thing as 2 times 2, 2 times 2. And so that is going to be 4. Or we could also represent it this way. 2 squared, because 2 times 2 is that way, equals 4. Now, let's, well, I should not have used that color. So 2 squared, or I should use magenta. 2 squared equals 4. Now, let's come back and look here. So we have a 6 and a 4. So now you can start to see, and this is going to be very similar to how we executed this LaTeX over here. So we did 2 times 2 times 2 times 2 times 2. So recall, when we multiplied 2 to the 4th power times 2 to the 6th power, we added the exponents basically to get 2 to the 10th power. And now we're basically, when we do the division of these, so coming back over here, yeah, I did want to show this. I'll come back to this. Hopefully I won't forget this. Basically, I just want to show like here's a cheat sheet of sorts of how to write certain things in LaTeX. All you have to do is just Google LaTeX cheat sheet, and you can find something like this. So I guess that's all I wanted to show with this is if you like this, I like this one because this one's a little bit more basic. Some of the other ones out there, if you just Google it, get pretty LaTeX goes pretty deep. If you want something that's more basic, I like this page here. But anyway, so back to what I was showing here. So 2 to the 6th divided by 2 to the 4th is basically subtracting the exponents here. So 6 minus 4 is 2. So that's why we have 2 squared equals 4. Now let's represent this in the form of LaTeX again. So this is going to be a jaunt, if you will, because I'm going to have to do a lot of typing here. All right, so I need to change this again to a markdown cell, markdown, and let's scroll down here. Okay, so again, like I said, I like to use the double dollar signs to put it in the LaTeX presentation mode. And all right, so we have that. All right, so wow, how do I do fractions again? Let me refresh myself. Oh, yes, it is just a \frac, F-R-A-C. So \frac, and then in the first parens, we're going to have what we have on the top, and then the second parens is going to be what we have on the bottom. So we have 2 to the, I need to refresh myself once again. Oh, I have it right down here on my surface. Duh. All right, so 2 to the 6th, 2 to the 4th, right? 2 to the 4th. Okay, so let's just go ahead and run that to show. So now we have a LaTeX rendered version of 2 to the 6th, 2 to the 4th, looking very nice there. All right, so now we want to basically say, okay, so this is the same thing as 2. All right, well, we need to do the fraction again. So frac. So that's going to be, I'm going to get a little bit lazy here because this is going to be the same thing. So 2 times 2 times 2 times 2 times 2. All right, so that. And then over, so the second curly braces is the denominator. That, again, I'm just being lazy because I don't want to have to type all that out again. All right, so that is the same as that. Now, here's the cool thing with LaTeX is you can do, if you wanted to create like this as a math lesson, which is what I want to do, is I wanted to represent, basically as we came up here, remember we did all the crossouts here, I want to do something similar with the LaTeX. Now, I'm not going to parse it all out as individual fractions because that would drive me freaking insane. What I'm going to do instead is I'm just going to represent it all as one and just cross out each individual thing from the top and the bottom. And so the way that we do that here is we actually, and this is the note that I had to make here, is you actually have to like do, it's almost like an import statement, if you will, you have to like import this cancel thing because this cancel thing is the strike through functionality. So let me go ahead and add that into my cell down here. All right, so I'm going to do that. Well, I guess I want to do this as a separate cell. I should have done that. So I'm going to do this as a new markdown cell. All right, so require cancel, $sign, $sign. Oh my gosh, if I can type. And I do want to rob this from up here. All right, I'm going to just grab this from up here, and then I'm going to do some canceling out. Okay, so that is good. All right, now if I run this, this is going to look the exact same. So let's go ahead and start crossing some of these things out. So all these are going to get canceled out. So this is going to be cancel, and I think you have to put it in the curly braces like that. So cancel. So, okay, so that, now you can see I just did it on the one. So let me go ahead and do it on the other. So the syntax there is /cancel, and then you put you wrap your value in the curly braces like so. So I basically needed to do this for all these things. So I'm gonna just copy and paste this. So copy and then replace the 2 here, replace the 2 here, and replace the 2 here. And then we need to do that several times up here as well. So cancel. Well, I'm gonna work my way backwards actually. So how many do I need to cancel? 4. 1, 2, 3, 4. All right. So now, that looks kind of hairy, but after we run it, now that's starting to look really pretty. So now you can see coming this, and this is again the power of LaTeX here is, so we went from 2 to the 6. So we did 2 times 2 times 2 2 2. So 6 2s there, 4 2s on the bottom, and then we just are showing the iterative process of crossing all these things out. So that what that leaves us with is, here, let's do another markdown cell, new markdown cell here, and that's going to leave us with the $sign. So 2 to the 6. I'm sorry, I need to do the fraction. So again, the numerator is the first curly braces, the denominator is the second curly braces, 2 to the 6th. All right, and then we have 2 to the 4th. 2 to the 4th, like so. What was I doing? All right, yeah, so equals 2 squared, or 2 times 2. Here, yeah, let me do that. 2 times 2 equals 2 squared. All right. Now we're starting to we're basically seeing the same thing that we saw over here. So we're basically working through the same thing that I did on a physical board. I guess this is technically digital, but imagine that this is an actual whiteboard, and I've got special markers and everything, and but then I can represent it back here in LaTeX, and then if I wanted to, I could even show this in the form of Python somehow. Now I'm not going to go that far because we're already starting to go along, and I do want to get back to what we are going to solve here because we're getting pretty close to being able to do everything here. Now, one other thing here, so how to handle negative exponents. So negative exponents, you actually take what is known as the reciprocal of whatever you want to do, and that like that is your answer. So that probably makes no sense. So let me go ahead and go back to my board here. I just erased it right now really quick. So let's say I wanted to take 2 to the -2. So that is the equivalent of saying 2 or 1 over 2 squared. And so we know what this is. So that is 1 over 4. Now, if that doesn't make any sense, let's go ahead and prove that out really quick. And I'm gonna. So this is again trying to build the intuition of why do we take the reciprocal of this thing here. So let's say we have. Hold on, I gotta Google this again really quick because I actually had to Google this. It's actually a very simple proof. So somebody on Reddit had a really nice little proof. Well, actually, I'm doing it on my other screen. Let me do it on my screen up here. So Reddit, what is it? negative exponent proof Reddit. Okay, hopefully I can find it. No, somebody else had a really good one. I don't think I Googled it necessarily like this before. Okay. Well, okay. So I think I could do this. This is going to be a little bit funky, but just go with me on this one. So let's say we have the value x, or well, we know the value number 1 equals 1. So 1 equals 1. And so then we can actually say, this is going to sound weird, but x to the 0 is actually equal to 1. So x to the 0, anything to the 0th power, and this is one proof that I'm not going to work out, anything to the 0th power equals 1. So 1 to the 0, so that's actually, let's do 1 to the 0. 1 to the 0 equals 1. And so then we can do 1 to the 1 minus 1 equals 1. So this is the same thing. So we went from 0 to down here to 1 minus 1. So we're not changing anything here. We're just representing the numbers a little bit differently here. And so this is when we, so 1 minus 1 is the same thing as representing this as 1 to the 1 power times 1 to the negative 1 power. And that's basically coming from the same rules that we learned before. So then we have 1 to the 1 equals negative 1. And that will leave us, well, I guess I should have not represented that with a number 1. So let me change this. So let's make this more generic. All right, sorry. All right, so let's say we have a to the 0, because this is, I mean, it would work with 1. It just gets a little bit confusing. So a to the 0, so a to the 1 minus 1 equals 1. So then we have a to the 1 times a to the negative 1 equals 1. And then so when we have a equals negative 1, that is the same thing. So because we have to divide both sides by a, so that is the same thing as a to the negative 1 equals 1 over a. So let me actually represent this again with the number 2. So, you know, number 2 equals 2. So 2, or I guess, or no. Or 1 equals 1. 2 to the 0 equals 1. So 2 to the 1 minus, or times 2 to the negative 1 to the negative 1 equals 1. So, and then we both divide both sides by 2. So that's going to be 2 to the negative 1 equals 1 over 2. And so that is, again, so like I said before, when we take it to the negative reciprocal, you know, 2 to the 1 by itself is just 2. And so then 2 to the negative 1 is going to be 1/2. And so I hope that kind of makes sense now. And the reason I want to bring that up is because that's kind of the final piece of the puzzle of solving this problem right here. All right, so again, so now we have all the tools to actually be able to solve this problem. And again, we don't need a calculator for this. We might need some paper, and let me go ahead and try to write this out. Here, let me write this, handwrite this first. I'm going to write this on my surface. So 2 to the negative 2 over 2 to the 0 to the negative 9. All over 2 to the 17th. 2 to the 17th power. Okay, so I just wrote that down on my surface. Now let me go ahead and write that in LaTeX here. So I'm going to create a new header here. I'm going to call this solving the Twitter problem, or the problem from Twitter. All right, so let's go ahead and write this as LaTeX. So what we have here, I'm going to do the double dollar signs, and then in the midst here, so we have a fraction, so backslash frac. Oh, let me make this easier for y'all to see. Sorry about that. All right, there we go. All right, so 2 to the, fraction. All right, so we're going to have numerator, denominator. So in the denominator, we just have 2 to the 17th. And remember, whenever we do an exponent with that is more than double digits, we have to wrap it again in the curly braces. So let's just show like 1 to the 17th right now. So just to show whether we're on the right track. So we have 2 to the 17th in the denominator, which again is correct per this problem. And then let's go ahead and represent that numerator correctly. All right, so the numerator is going to be, what was that? Okay, I have it written here. So another fraction. So fraction within a fraction there. So I'm actually going to put some parens here as well. So it's actually going to be to the negative 9th power, negative 9. Okay, and then we need another fraction in here. So frac. So this is going to be numerator, denominator. So what is that? Negative 2 and 0. Negative 2 and 0. Uh-oh, I did something wrong. All right, what did I do wrong? All right, so we have our numerator. Is it because I tried wrapping it in parens like that? What did we do here? I don't know what I did here. Oh, I think I accidentally represented one of those curly braces a little bit odd. So there we go. That fixed that. All right, so kind of. Well, so 2 to the negative 2. Oh, so it's 2 to the negative 2. And then I want to wrap this whole thing in parentheses. So again, this can get a little bit hairy to write, and this is why, again, this is not technically a programming language, but it kind of feels like one because of the complexity in trying to write this thing. Okay, so now I think this is right. All right, so let's do a quick check. So 2 to the negative 2 over, oh, it's not 0, it's 2 to the 0. Sorry about that. 2 to the 0. All right, so 2 to the 0, all of that to the negative 9th over 2 to the 17th. And that is correct. All right, so let's go ahead and solve this, not in LaTeX, because I'm too lazy to write out any more LaTeX. Let's go ahead and solve this by hand. So first things first, so 2 to the 0, we already know is 1. So we can go ahead and represent that as 1. So let's, and because it's 1, so anything that's over 1 is going to be itself. So this is already, so again, this is going to be 1. Or, let me change colors so you all can see very clearly what I'm doing. So this is equal to 1, and so this is now going to become 2 to the, 2 to the negative 2 to the negative 9, to the negative 9. Am I doing this right? Yeah, this is right. All over 2 to the 17th power. Now, one thing I'm realizing that I failed to mention is, we talked about what is 2, like when you have the same, so this is, the 2 here is represented or called the base. So we talked about like what is 2 times 2 times like 2 times 3. So we talked about how if the bases are the same here, then we just add the exponents. Now, if we're just raising something to a power, we actually just multiply these two things together. So now we have, so if we multiply these two things together, these two things, I hate what, that's the one thing about this Nebo is it likes to do this, like create straight lines for me. So if I multiply these two values here, this negative 2 here, and this negative 9 here, we have a positive 18. So negative 2 times negative 9. So that leaves us with 2 to the 18th, 2 to the 18th, all over 2 to the 17th. Now you can see that, because we talked about this as part of this notebook up here, is when we divide exponents like this, is basically representing this out as 2 times 2 times 2 times 2 times 2, and then 2 times 2 times 2, and then all the tops and the bottoms cancel each other out appropriately, and then we are left with just whatever is left. So coming back to our problem here, and I am explaining this once again very poorly, so apologies if you're having a difficult time following along. But basically, we're going to take 2 to the 18th times 2 to the 17th. So this is basically we need to subtract this 18 from this 17, and that's going to leave us. So that's going to leave us 2 to the first power, which all equals 2. So this whole hairy expression up here, this whole thing, the simple answer is actually 2. And so you can actually see that some people did that here as part of the Twitter replies. And that's why I really like this account, is because there's a lot of interesting little math problems like this where, sometimes they don't come out as clean, but it's really cool when they come out super clean like this. Now, how much do I want to represent this as LaTeX? Because I think I already showed you enough. Because it's basically, well, I guess I'll go ahead and show. No, I'm too, well, so, am I too lazy to do this? I feel like I'm too lazy to do this. Well, I'll go ahead and I'll do it. So, all right, so let's call this, step one, or original problem, or I'm going to call this original problem. Okay, so that's the original problem. Now, so step one, what we did was, oh, sorry, I got to change this to a markdown cell. I keep forgetting to do that. Any questions? Because we're getting close to the end here. I guess that didn't go as nearly as long as I thought it would. I felt like this, when I prepped this stream, that it was going to go on for freaking ever. Okay, so remember with step one, so we represented 2 to the 0 is 1. So 2 to the 0 is now 1. Or I guess we could show this equals this, and we're just going to change this to a 1. Ooh, did I add an extra character in there? I feel like I did. No, I didn't. Okay, I did that right. So as you can see here, so we went from this to this. So 2 to the 0 equals 1. And then so step 2 is basically, we're just going to keep going on down the line. All right, keep adding more markdown. Well, I don't know. Well, yeah, never mind. Sorry. I don't know why I keep doing it like this. All right, so step 2. So we're going to take this part out. So we're basically going to say this is the same thing as this. So, because remember, we're basically just going to omit this here. I need to rerun these cells. All right, so because remember, anything over to the first power is just basically itself. So we're basically just going to take away this fraction. So I'm going to take away this 1, and then I'm going to take away the fraction associated here. So that's just going to be 2 to the negative 2. Did I do that right? I don't think I did that right. Yeah, I missed a parenthesis. Okay. Yeah, that's correct right there. Nope, not a curly brace. Parenthesis. Sorry about that. Okay, so again, we went from 2 over 0 equals 1, and now we're going from 1 to just, removing that just for simplicity's sake. All right, so now we are going to take this part here, and we're going to go on to step 3. So if you recall, I need to make this a markdown cell again. All right, so step 3. 1, 2, 3, step 3. Oops, I'm an idiot. All right. Oh my gosh, click that thing. All right, there we go. Boom, boom. All right, so that equals basically the same thing, except now we're going to have, so we're going to multiply these exponents together because we're taking 2 to the negative 2 times 2 to the negative 9th. So we're multiplying the negative 9 with the negative 2. That makes a positive 18. So now we can basically take out this whole top part and replace it with a 2 to the 18th. But remember, if we have double digits in our superscript, then we need to wrap those in curly braces. So now we have 2 to the 18th, and now we're getting close to the end. All right, so that was step 3, making a markdown cell. I need to learn the hotkey for how to do the markdown cells. All right, so step 4. So step 4, we are going to start with this side. Oops. Sorry about that. So that is 2 to the 18th over 2 to the 17th equals 2 to the 1th power. And that's all just going to equal 2. All right, so we took that same problem, and I hope you all learned something today, because that is the solution to the same problem that we started with over here on Twitter. So just again, a quick recap. And we did that all, and then we represent that all in LaTeX. So we got the original problem. And then first step is representing the 2 to 0 as a 1, which we did it over here. And then I just removed that 1 just because anything over 1 is that same number. So that is what we represented here. And then we multiplied these two exponents together, negative 2 times the negative 9. We got positive 18. So we have 2 to the 18th over 2 to the 17th. So as we learn from up here, when we can just start canceling stuff out, because after we expand the terms, then, and I'm not going to do that because I'm not going to freaking write that 18 times. Like that would take forever. So 2 to the 18th divided by 2 to the 17th is the same thing as 2 to the first power, and 2 to the first power is obviously 2, and boom, we did it. All right, hot dog. And now you can kind of see. I hope you can kind of see why math can be kind of fun. Like, because when you start to understand kind of stuff, it's like solving. It's like solving problems. Like solving I mean, I'm trying to phrase it differently. It's like trying to, like, because I like to play a lot of video games. It's like solving a puzzle. Yeah, there you go. It's like solving a puzzle. And so I know a lot of people out there like to do crossword puzzles and whatnot, and they would never see math or understand math as being playful and fun like this, but it actually can be. And I actually enjoy going to this individual's Twitter account here and looking through these problems here and trying to solve them myself, because it's actually kind of fun. Like when you start to understand some of these mathematical principles and trying to solve them, it's just like doing a Sudoku puzzle or whatever. So I hope this is also a stream that helps to reinvigorate your interest in math, and to understand like math can actually be pretty fun, and it can be daunting, but when you understand the intuition of why we do everything, and that's what we were trying to do here, or I tried to do here in the form of showing all these things, is when you understand the intuition of these things, it's like it's actually pretty elementary. Like solving this problem in my mind was pretty dang easy. And again, we needed a paper or we needed a LaTeX to represent this out. But again, we did not need a calculator to get this whole thing. Now, we could have, like this thing could have exploded, and like this thing, it could have been 2 to the 500th power over 2 to the 400th power, and then we would have had to do 2 to the 100th power, and I don't know what that is off the top of my head. That would have required a calculator. But it is... I hope you can see how this is fun. And then I also hope you also see, generally speaking, how this can be very powerful for the data science community, or how Jupyter Notebooks, with this whole combo of being able to write code in Python and then being able to represent things like so, and then actually being able to write plain text. And then even, I've done in previous streams where we did data visualizations. This is why Jupyter Notebooks are awesome. I love Jupyter Notebooks. Now, I will say Jupyter Notebooks are not, the end all be all for every scenario. But for these sorts of scenario where you're trying to explain a concept, or you're just doing what we call general data science discovery work, Jupyter Notebooks are awesome. So that's really all I want to cover today. I got a little bit of a stuffed up nose. It's freezing here in my office. My office is here in my basement, and I don't have any... I actually have all the vents closed down here because I typically, I don't know if you can see this, I actually have like a space heater down here. This is what I'm pointing at. And I don't have it on right now because it's pretty loud, but that's how I heat my office. And I forgot to preheat my office before I came in here because I have everything set up to where I can like turn things on and off from my phone. So I can say, turn on the fireplace heater, because it kind of looks like a fireplace. And then Siri will turn that on for me. But Siri's, well, I'm still talking. Let me stop talking for a second. Yeah, so you can see that the fireplace heater is turned on now. Or I could say turn off the fireplace heater. Okay, and so usually in the morning, like I'll from my phone, I'll start that heater, but I forgot to today, so it's cold in here, and that's why I've got kind of a stuffed up nose. So I hope you all enjoyed this stream. Like I don't know if I'll do anything more like this in the future. Like I'm just kind of deep in the weeds of learning math myself, and I'm having honestly a fun time kind of doing it. So I'm getting close toward the end of Algebra 2, and I hopefully will wrap that up this week, and then I'll move on to trigonometry, doing it all on Khan Academy, and then what's after trig? I think I'm going to go on to statistics, and then calculus after that. So, and again, having a really fun time doing it, because when you really start to understand the intuition behind these things, math can be pretty fun. Like genuinely fun. Like I'm not just, or maybe I have a weird idea what fun is. So, okay, I'm going to go ahead and call it there and go blow my nose and eat some lunch. So I hope you all have a good weekend. I am glad that the stream actually worked this time. So again, apologies about yesterday. Reminder again, no stream next week just because I got to take care of my kids. But I hope you all have a good one, and we will see you in probably 2 weeks. So thank you all for watching. Have a good weekend.